All right. That doesn't seem safe. So I clicked on login with Google, but I thought, oh, I think I actually have a normal account with this one. So I hit cancel, and then I was just logged in. Okay. Who? My course. Pass something. All right, so we are this one. And I'm going back to the very beginning. This introduction. All right, we already got Unity. We already installed blah, blah, blah. And we looked at its interface and crap like that. We're all experts now. So we're going to look at the Save the Golem game thing. He doesn't do very much teaching in this, but I'm going to stop at several different times and talk about it. One thing I'm going to go ahead and do right off the bat is I'm going to grab these couple of, I'm not going to grab the project because we're going to create that project. This is kind of like what your final thing is going to look like. But I'm going to go ahead and grab the assets zip file and download that to, I'll just put it in downloads for right now. And then I'm going to go ahead and extract it. So I have the, oh, it looks like I already have those in here, but I'll extract it again anyways. Okay, so I have all these files. These are going to be the ones he's going to reference for getting in models for our dude looking awesome, for pumpkins and golems and that kind of stuff. And then also textures for also making things look good. All right, so we don't have to worry about that. We're going to be dealing with things in terms of generic game objects and throwing the assets he's handed us on top of those, and you'll see how we can make things look pretty good pretty fast. All right, so I've already done that, so I'll just close that so I have those prepared. And we're going to go ahead and play this video. Like I said, I'm going to stop it pretty often, but let's see if we can at least get the sound loud enough.
What is up, guys? And I want to ask you a couple of lines of code, a simple idea to become awesome and playable game. So I'm here in my Unity. I've just clicked on the Unity icon to open it. And this is what I have. These are my projects that I worked on that you will also be working on in the course. But enough about that. Let's go and click on the new project and create a new project. Let us just wait for Unity to open all of that. I am going to turn this off because I don't want to enable Unity Analytics. For 3D here, we're going to check it. We're not going to check 2D because this is a 3D game. And this project is going to be called Golem and Pumpkins, like this.
All right, so let me go ahead and do that. So I'll pop open Unity here. And we will create a new project. He turned off the analytics. Probably didn't matter if you did that or not. And we're going to call this Golem and Pumpkins. I'm going to call this guy 355. Just because I think I have another folder in there named something similar. And it's going to be 3D for starters and create project. So let that cook. Let him keep babbling.
Now, depending on where you want to save it, I'm going to save it right here under this location. So project, course project, and I'm going to click open. You can save yours on the desktop, on your cloud, or I don't know, in your room, wherever you want to save it. And I'm going to click on create project, and it is going to, well, create that project for me. And just like that, bam, magic, here is the project. Let me just clear everything here in the console that we have. By the way, if you are wondering why my setup is like this, well, because I have drag and drop these. And
I promise you I was doing this before he was. Moving the hierarchy over here. But you'll see pretty quickly that this is super handy as you're dragging stuff from here over to here. It's hard to click and hold for that long sometimes, at least for me. But especially when you're using a mouse pad. I keep forgetting to bring my mouse, but whatever.
And we talked about this. You can drag and drop these, arrange them however you want to arrange them. You can save these layouts after that. So simply click on Save Layout and then click, well, name it here however you want to name it, and then click Save. This arrangement here depends on you. It's not like you need to arrange it like this. I like it like this, but the default one is this one right here, which is the one that you probably see. If you don't like it, put the hierarchy maybe here, or maybe you like the hierarchy floating, so make the hierarchy float, whatever you want to do. And if you want to save the arrangement that you have, you're simply going to go here under this top right drop-down list in the top right corner, and then click on Save Layout, give it a name, press the Save button, and voila. Mine is this one, my layout, and this is, well, how I like it. Enough about me babbling. Let's create a new folder here in the Assets folder by right-clicking and go under Create and New Folder. And quickly, I'm going to name it Scenes and save the current scene that we are in.
All right, so we'll go ahead and do that. I'm in my project folder here. Oh, the new version of Unity already gives you a folder called Scenes. So we've completed that step.
There are two ways to do this. Go under File and click on Save Scenes, or Command S on Windows is Control S, and this will pop up window will open. And here I'm going to select the Scenes folder and name it Gameplay. Hit Enter, and the scene is saved. If we go in the folder, here it is. This is our scene. Now, don't worry, we will talk in more depth about scenes. What are scenes? How can we navigate from one scene to another scene? So on and so forth. So we'll see all of that. But in short, this is a scene. Everything what happens in your game is actually, well, going to happen in the scene that you are currently in. And we will see all of that and how can we create multiple of these and how can we change or go from one to another. So don't worry about anything if it's not 100% clear. It will be when you dive deep in the course. Next, we're going to import all of these assets. So we have the models, we have the textures. They are available under this video for downloading. At the top left corner, hover over it. Download these project files along with the complete project. So you can download both of these, but when you download...
So we're going to go ahead and bring those into our project. A couple different ways you can do this. You can open up the folder next to it. Go to Downloads, find my assets. Here's those two folders here. And I can just drag them into my project. The other thing you can do is you can right-click inside of assets and say import, and you can bring in assets from the outside. All right, so there's my models and my textures.
Oh, the assets, these two is what you're going to see, models and textures. Simply drag them and drop them right here. So drag and drop them. That is all you need to do. Select them, then drag and drop them in Unity. Wait for Unity to import all of your assets because as you can see, Unity is currently importing them. So it takes a little bit of time sometimes depending on how large the assets are. And voila, we are done. The first thing that we are going to do is create our floor. And in order to create our floor, right here in the hierarchy panel, I'm going to right click and I'm going to go under 3D object and I'm going to create a cube. And voila, here is a cube, right?
So we talked about this a little bit before. We created a floor that was made out of a plane, right? He's creating a floor that's made out of a cube. Cubes will have a box collider versus a mesh collider, and box colliders will give us, remember when we had something that had a lot of mass and it fell right through, a box collider will give us more collision points. So you can kind of choose which floor you'd like to have, because what he's going to do is he's going to make this a floor, but then squeeze it down to something fairly thin, but it's maybe a more robust floor or something like that. So we'll let him do his thing.
Okay? Just kidding. And I'm going to rename it from cube to floor, and I'm going to position it at 0, 0, 0. And now I'm going to take and resize it. How are we going to resize it? Well, here in the inspector panel on the right side, you have something called a scale. You see when I scale it on the x-axis, it's going, you see? So it's going wider. If I scale it on the y-axis, it's going taller. What we want to do is set the x-axis at 30. Set the y-axis at 0.1 because we want to make it a little bit flatter, you see, flat like this. And set the z-axis at, let's say, 50. This is.
All right, so we'll go ahead and get a cube in here. So we'll go into hierarchy, right-click, 3D objects, cube. It's going to throw one in there. If it didn't already put it at position 0, 0, 0, go ahead and put it at position 0, 0, 0. All right, and then for scale, we're going to have 30 by 0.1 by, 50? And then he renamed our cube to be called floor. All right, so far so good. What?
Little like light for the sun kind of thing.
Yeah.
This became a lot.
Oh, you probably had that selected when you added your cube. So did yours do something like this?
Yeah.
All right, so just drag the cube out of there. So it's no longer a child of it.
Oh, okay.
Because when you had the cube as a child of it, it became effectively attached to it. So then once you have that, you can go ahead and take your floor, or it's probably still called cube for you, and change its position to 0, 0, 0. Because right now it's probably wherever the directional light was.
Right.
And then scale it 30.1, 50. We're in good shape now? All right. Yeah, so related to that, a good rule of thumb, because that'll happen often, where you'll put something in, you'll not realize, like right now, if I were to add something new because I have floor selected, it's going to add it as a child to that. So kind of a good rule of thumb, unless you're purposely adding something as a child, just click in here once, click in the hierarchy once to unselect everything. That way you're adding it at the top level, and then you could drag it wherever you want. But it's super common what happened to you. That happens to everyone because you forget to unclick something. The other super common thing is we make changes while the game's running and then stop it, and then are surprised that our changes didn't stick because we made those changes. All right, so keep trucking here.
This is what we want. So this right here is our desired floor. Now that we have our ground, let's apply a texture on it so that we can change this default white color that it has. For that, we have this texture inside of the textures folder, this ground one, and we're going to apply it on our ground.
All right, so we've done this with materials. So now they've done it with some textures. So if you select the floor, a couple different ways we can do this. Select the floor. We see the floor over here in our inspector. We'll go into the textures folder that we grabbed from the from Udemy from his assets, and we have our ground. Now we can drag that ground right onto the ground here. Similarly, we can select the floor and we can drag ground over here onto the inspector over here. Okay, notice that it put the ground on there. It treated it like a material. This kind of looks like a material dealy, but it's actually a texture what we did. So you can either drag it over to the inspector or you can drag it right onto the floor. I mentioned this before. What's one problem you might run into when you drag something directly into the screen? Why might you not want to do that often? Why might it be smarter to drag it over here to the inspector versus dragging it right onto the element? What do you think? Our example here wasn't a big deal because I really didn't have, I only had one big target, right? But if you start having a scene with a lot of stuff happening in it, when you drag something in, especially in 3 dimensions, you have all sorts of stuff you might accidentally land on. You might accidentally overwrite another texture or something like that. So if you're trying to be precise, you probably want to get in the habit, in my opinion, even though you will see him in the video pretty often dragging it right into the scene. But if you want to be precise and not screw up very often, you might want to get into the habit of going into your assets, getting yourself positioned where you want to be. So in this case, I have the texture I'm going to apply here. Then select the floor so it's loaded into the inspector, and then drag that guy into the inspector as a new component and let go. And then you know you're adding it to the right game object. That make sense?
Now we can drag and drop it like this right away. It will be applied on the ground. But what I want to show you is that we can create a new folder and name it materials like this. And inside of this folder, right click, go under create. And this time we're not going to create a folder, but you're going to create a material. You see here under create, you have this material. When you click on it, it will create this right here called the material. And I'm going to call it ground. And now we can apply this on the ground itself. But if we drag and drop it, you see, I'm not dropping it. I'm just dragging and hovering over it. Nothing is happening. But if I click on this albedo right here and search for the ground, you see here is the ground, or you can filter inside of this pot.
So what he's doing right here is effectively what it did for us here. This guy is a material. It created for us behind the scenes. What we don't then have is we don't have a folder called materials. Oh, actually, we do. Look at it, generated for us. So we have a folder called materials, and we actually have the ground. So the newer version of Unity is doing some of these steps for us. That makes sense? So that we didn't have to.
Pop-up window, you can filter for ground. Select the texture. So now the texture is applied, and you need to do this under this albedo right here. So the texture is applied, and if I hover over with the material selected, you see it changes now. You see, it is changing the appearance of our floor.
So that is one way you can kind of make sure you're hitting the right thing, is when you hover over it, it starts changing it. Notice that it did not do that when we first just drug the texture over there, because the texture is just an image. We created a material from that image, and Unity did that for us as opposed to he's here manually doing it. But it can't apply a texture directly to a game object. It needs a material to do it. So if you have a material, it'll show you a preview. If you don't have a material, but it can make a material out of it, it'll show it as being an available place to drop, but it's not going to pre-light it for you.
Now, if we drop it, this is how our floor is going to look like. And this is how we change the appearances of our 3D game objects inside of our scene by applying materials. Now, you see here in the inspector panel, when we select the material, you have something called a shader. You see this ground, this is actually called, or below it, it has a shader. This is a material, but it has this shader. And this shader will determine how this material or this texture will look like. Currently, it is set to standard. I'm going to go into legacy shaders and set it on diffuse. But before I click, pay attention on the ground itself. So when I click now, bam, you see the ground has changed a little.
Okay, so we go and do that. We'll select our material. We'll click on shader for this guy. Now we can do this at a couple different levels. If I go to floor and I go to the ground and I change the shader on this to legacy shaders diffuse, it changes on there. Now what I want to look at here is, yeah, it changed it to the original material. I wanted to see if I could change it just as it applied to the floor or whether it made the change to the actual material. It made it to the top level material.
a little bit. So depending on which shader you select here, the ground or the appearance of that material will change a little bit. And we will talk a lot about this in the course, so don't worry about it. The last thing that we're going to do is slightly make our floor to be a little bit inclined. We're going to do that by rotating it by 10 on the x-axis. You see, we have rotated it on the 10 on the x-axis. So,
all right, he's going to take advantage of gravity here. So rotating it by 10 on the x-axis. I'm going to go ahead and zoom in here. I'm going to look at it on x so we can see the thing is rotated at a slant. Because when this thing is done, we're going to be dropping effectively spheres that look like pumpkins up here and watching them roll down the thing like we did in class last time, right?
So what is the next thing that we need to do? Well, the next thing that we need to do is import our pumpkin inside of our game. And the pumpkin is like the main villain inside of our game. And let's do that. So if we go into assets, models, we have here Golem, which is the Golem folder. We have the pumpkin. Here it is, single pumpkin. This is the one that we want. So here is our...
So let's get that guy out here. So I'm going to go ahead and put us back on the... Let's go on the Z. Okay, I'm going to go into assets. I'm going to go into models. I'm going to go into pumpkin. And we have this thing here called single pumpkin. Now, this guy is actually something that's called a prefab. All right, and we're going to learn about making prefabs. Actually, we're going to make one here in a few minutes after we add the orange or yellowish. I think we get to choose some colors, but we're going to make a more permanent pumpkin prefab that we can then use multiple times. So I'll drag this pumpkin out here. All right, so there's our pumpkin. It's just on the scene so we can see it.
Pumpkin, this dude right here. Now he looks all white and we need to apply materials on him, but what we're going to do is simply click on the drop-down list in the pumpkin here in the hierarchy. Select this sphere, which is the second one, and we have the brown top and orange. So simply select the brown top, click on the drop-down list.
So just as an example here with that whole thing having certain things as parents, notice that when we drug the single pumpkin out here, it's a collection. So this guy actually is an empty game object. Single pumpkin is an empty game object that has two different game objects inside of it. It has a sphere, which is kind of flattened, which is the top part of this guy. Okay, you see this dude right here? It's the very top disc. And then it has the larger sphere, which is the bigger pumpkin dealy thingy. Okay. So that means we're going to be able to apply a material to two different places on this guy. So maybe, you know, has kind of a darker stem and an orangey color for the pumpkin itself.
Please. Here for the albedo, we have this color. When you click on it, this pop-up window will pop up. So when we have this pop-up window, we can change the color. I'm going to set it something like purple. This is just for the, well, the top of this pumpkin. And for the bottom, I'm going to select this one. So orange, this one right here. Click on this color palette, which is right next to albedo. So to the right of it. When you click on it, I'm going to go and let's say something like this. Yeah, this is our pumpkin. Purple top, and this is how I want it. Now we're also...
All right, so let's get something like that going here. So when I click on that top guy, notice he already has a brown top and an orange. So for brown top, now one thing you're going to see right now is you are not able to edit this guy. If you actually go into the course and you look at some of his rules or whatever, you'll see that this is because it was part of a prefab and it was kind of like it was supposed to be permanent. So we're actually going to have to create our own material out of this guy, not the end of the world. So I'm just going to come in here. I'm going to create a little folder called materials just to be official. And that's, you know, for organizational purposes. And then inside of materials, I'm going to create a new material. And I'll call this guy STEM. And then I'm going to create a second new material. And he called it orange, so we'll just call that orange. All right, then I'm going to go back to the top sphere on my single pumpkin. Here, we'll change the stem to say brown underscore top, so it's matching what he has. All right. So I'm going to say select material. And the material we're going to select is from our materials thing, and we're going to select brown top. And now that's going to allow us to change this guy. So we'll click on Albedo. He kind of picked a purpley color like this. Oh, it's not popping up in there. So I think we have to delete this and re-add it. So I'm going to Am I not able to delete the component? Well, what I can do here then is I can click on brown top that I created. I can say copy material properties. Then I can go into sphere, right click on brown top, say paste material properties. Yeah, that allowed me to override it. So I created my own material that I was able to, once I selected it, showed up in the inspector. I could hit this little gear here. I could copy the properties of it and then go into our sphere and right click on this guy and say paste material properties, and that got it in there. Similarly, I'll choose for our orange here. This is the material I built. I'll go ahead and he kind of made it like a yellowish. So make a yellowish color. Then right click on orange. I'm sorry, don't right click on it, select it. Then go up to the inspector, hit on the little gear, say copy material properties. Then click on sphere. Go to orange here, right click on it, and say paste material properties. And now we have our yellow pumpkin guy. There's some different ways we could have accomplished that, because I think our sphere guy here is the guy that has the orange. So I was hoping we would have been able to remove this component. So probably in the end, what we would have had to do is maybe make a duplicate of this single pumpkin, which then we can edit. But we accomplished the same thing in the end. We probably could have also, could we have changed it in here? It doesn't look like it. Okay. But we have our guy with some color now.
We're going to resize the pumpkin and rename it. So here, instead of single pumpkin, we're going to rename it to pumpkin. And we are going to resize it by, well, filtering or changing the scale. So the scale is going to be 0.85 for the X and the Y. So 0.85, let me just copy paste. So 0.85 X, Y, and Z.
All right, so we renamed this guy Pumpkin. And he scaled it to 0.85. Now, one thing I'll point out here, so when this guy rolls, let's see, do we have colliders on any of this right now? We don't. Chances are when we put a collider on this guy, we're going to put a sphere collider on this. So he's going to roll as if he's a ball. Now, if we wanted to put an additional collider, maybe just on the stem part, that might make it roll a little funky, right? We can, because then you kind of have a little knob, which would actually probably be how a real pumpkin would roll. But what we're going to do is we're going to make this guy roll in a predictable way. So we're going to put a sphere collider. So this basically the stem is there just for looks. You know, it's not going to impact how it's going to roll when we actually go and actually make this guy roll.
This is going to be the scale of the pumpkin. And this is, well, how large the pumpkin is. Let me just take a look at it like this. If I select the main camera, so notice now when I put my view inside of the scene right here to look at where we are currently looking and select the main camera, because the main camera is looking at this currently. If I put the view right here and select the main camera and hold Shift Command and press F, the camera.
So this is a good trick. All right, so right now, if I click on the camera, we're pointing to a completely different place, right? Now, we can sit there, we can fart around with the camera and try to get it, you know, angled just right or something like that. But if we go ahead and we kind of just position our screen the way we like it, I'm going to just put it. Let's say that's perfect. All right. So once we've done that, then make sure you select the main camera and it's Control Shift and F. On the Mac, it might be Command Shift F, but I think it's Control Shift F because he's actually on a Mac and he mentioned that. And what that will do is it will position the camera to point to the exact same place that you're looking at. It's a nice quick way of kind of getting the camera looking at the thing you want it to look at. Make the screen look the way you want it, click on camera, Control Shift F. Make sense? Okay.
Will arrange itself to look at, well, where we are looking inside of our scene. And we will change the position of the camera later on, don't worry about that, but this is what we currently see. The next thing that we want to do is add a rigid body and a collider on our pumpkin in order to make it move. So select the pumpkin, go under Add Component, and here we're going to filter for a sphere collider. So sphere collider, S-P-H-E-R-E. So sphere collider, here it is. Click.
All right, so we're going to go ahead and we'll click on our pumpkin here. So we're doing it at the top level for that guy, pumpkin, add component. Here's our sphere collider for this guy. Then we're also going to add a rigid body to this guy, so we'll go ahead and do that. So add another component, rigid body. All right, now we added this sphere collider. I'm going to go ahead and zoom in on the pumpkin here. Now, if I click Edit Collider on the Sphere Collider, we see what that sphere currently looks like. You see how it just put this little tiny circle? Well, it is a sphere, but it's down here kind of at the bottom of it. We're ultimately going to want that to be a lot bigger, right? We're going to want this guy to be the size of our pumpkin, something like that. My guess is he'll probably give us a more specific center. So maybe the center is going to be like 1.85 or something like that. And then maybe 0.5 on the Z. I'm going to look at this guy from above. All right, so now we can kind of see that it's a little bit off center on our pumpkin. So I clicked on Y. Pumpkin selected. I'll click on X here. So if I want to see this guy from the top, I click on the Y and I can see that it's a little bit off center here. So I'm going to mess with the center of this guy, maybe 1.5. That moves in the wrong direction. So maybe 2. Well, doesn't really seem like that's changing it very much. I set it as a 2 right now, and then I'm going to drag it around in here. Move the X some. I'll move the Z some. Okay. That looks pretty close. Whatever, something like that. If we then look at it on the X, we see that the guy is actually too low right now. So we can move wrong way. Move on the Y, get that guy up here in position. So you can look at it from all the different angles until you feel like you have somewhat of a, I move that on the X just a little bit. Something like that. And they can also play with radius a little bit to get it kind of tightened in on the size of this guy. We're not going to be able to really notice the difference here. And then we can move the X. We can move the Z. Call that pretty good. He's going to give us probably some exact numbers to put in here to make it just so. All right, but we look like we have roughly a circle thingy. Okay. Now, another thing I'm going to do with the pumpkin right now is I'm going to go ahead and I'm going to click on Move Tool. So I'm going to unclick Edit Collider. So we're done editing that guy. I'll click on the Move Tool here, which gives me my arrows. And I'll go ahead and move this guy up into the air a little bit. Because right now he was actually already colliding. We had him below the surface of the floor. So I'll move him just up above the floor here. I'm going to go on to the Y. I'm going to zoom out here some. And I'm going to move him up near the top. Flip over on the X. We can kind of, oh, he's actually moved to the bottom. Okay, so now I need to move him to the top. Double click on pumpkin to zoom in on him. So these are kind of those skills you start getting used to. How do you manipulate this 3D world? So get him hovered above the floor here. Look at it from the Y, make sure that looks pretty good. It does. Look at it from the X. Look at it from the Z. All right, so then if I zoom back out, there's a pumpkin that's way up there. All right, and this guy has a sphere collider, so he'll collide with stuff. He's also a rigid body that uses gravity. Now, when we hit play, we're going to see that this guy hits and starts rolling. But he's rolling like a normal sphere, right? And now he's falling to his death. All right, if we wanted him to move a little funky, we could have gone in here to our sphere, our top piece here. And I mean, we'll just do it real quick here. I'll add a little box collider to this top guy. And I'll edit this. And we'll just squeeze the size down a little bit. I'll look at it from the top. So we'll squeeze the Z down. And squeeze the Y down. We'll look at it from the Z. Okay, so we basically have a little stem there. Okay, I'm also going to make, so let me just show you right now. So I'll go ahead and hit play on this guy. So see how he's kind of bumping a little funny? Okay, but he still rolled relatively evenly, right? We just had him bump up there a little bit because of that stem. So maybe it looks a little bit more realistic now. But that's because we have a sphere that's rolling evenly. And then we have this box collider, so it's always just going up on its tip, right? Something like that. So you know, we would have to create a different type of collider, or maybe make this guy, we can probably do, instead of a box collider, let's just kind of play devil's advocate here. I doubt it's going to make a difference. We maybe can make it make a difference. We can create a capsule collider, which will have kind of a curved end to it. But unless we have some sort of force that's pushing our pumpkin from side to side, we're never going to get over on one of those curves. We're always going to be right on the top of it. But if we wanted this guy to roll like a real pumpkin might roll, we can mess around with colliders a little bit, maybe do some randomization on forces to get him just a little bit off kilter to start rolling a little funky. The other thing we could do is maybe put some almost like pebbles along the, because right now we have a smooth floor, so we can put little notches along the line. We don't even have to have them be visible. How can we put, based on what we've learned so far, how can we put little, bumps in our road that don't, or in our floor, let's say, they don't actually look like bumps? How can we make it be a bumpy floor? Okay, but we can only add a box collider to a game object. So you're right, but we need to get to the point where we can do that. So you want to add a whole bunch of box colliders, right? So he has things to bump into. So hey, if I want to add a bunch of box colliders to that floor, I can only add one box collider to one game object. Okay, well, but that it's going to maybe look ugly, right? So now you have a whole bunch of little boxes. What if I don't want to change the look of my floor? Yeah. So we can make an empty game object, place them where we want to place them. Similarly, what we could do is we can make a box, as you suggested, and then we can turn off the shader and the mesh renderer. We can turn off the renderer, actually, will do enough, which will make that cube invisible. But we might as well make a game object. So almost kind of, we'll just go do that real quick here. So I'll go back to, I'm going to zoom on the floor. I'll zoom in on this guy. And I'll go ahead and add, I'll create an empty game object here. You know, actually what might be easier, I can create an empty one, but we're actually going to go with the box one. And the reason for that, or the cube, is so I can see it when I place it. And then I'll just turn off the renderer so it no longer is visible. So I'll actually create a cube. So there's my cube. And let's see where this guy, okay. That looks like it'll be a nice little bump in the road. Looks like he's going to be in his way as he's rolling down there. So we'll go ahead. We already have a box collider actually on that guy. So we'll leave him there just for the moment. Okay, that got him a little off kilter, right? So we can certainly play around with that and get it looking, maybe getting it a little bit better. But if I click on this cube and I turn off his mesh renderer, now he's invisible. So I didn't remove this component. I just turned it off. I disabled the component by hitting this checkbox. So now we no longer see it. Right next to mesh renderer, if you click on cube. All right, if we want this guy to act a little funkier, we probably can change I'm going to go ahead and remove the box collider from this cube. I'm going to add I'll add a sphere collider. I'm going to zoom in on the cube here. I'll edit that collider. I want to see it from the side here. Well, let's see what this looks like. It's basically a sphere collider at this point. Oh, it is a sphere collider. I meant to hit a capsule collider. Let's see if we get a funky look. Nah. Probably did better before. So let's actually then put our box collider back in. I'm going to edit this guy. And I'm going to make the size a lot smaller. And I'll also change his center just a little bit. Should be kind of a off-center rock in the road. So hopefully he hits this and kind of zigs off a little bit. Oh, yeah, I think he missed it, but whatever. Screw with that for a while and get the thing looking like it is doing something. He's not doing this in this game. He's having the thing roll in a predictable way because we're going to be dodging it with our golem. But we kind of see that these are things you can do to play around with the physics engine without us doing any programming at this point. We haven't written one script. Okay, so I'll go ahead and get rid of that cube. I'll go into my pumpkin and I'll go to that top sphere. I'll go ahead and dump that box collider that I added to it. So now it should just be a plain Jane pumpkin. Although, you know what? I kind of liked the way it looked when it just kind of, it still rolled straight, but it rolled like a pumpkin might roll. I might leave that in there. He doesn't do it, but I think that looks kind of good. Adds a little realistic component to it. We almost bounced there a little bit as he started picking up speed. Yeah, I'm gonna leave that in there. That'll our own little taste to this. All right, I'm also going to Control Shift F. I didn't like the way it was showing up on my screen. I'm going to change the view just a little bit. Yeah, I think that's a little bit better. It's all personal preference.
If you're gonna like rotate the pumpkin, at the very top, you're gonna start rolling that box collider.
We could do that with a script. Oh yeah, well. Okay, if we kind of could create a little bumps in the road just in the right place, kind of mess with it for a while until, you know, we kind of got it knocked until it started spinning, you could do that. You could also add a little bit of an arbitrary force to it. You know, we can do that with a script, you know. So we kind of have two choices. We can programmatically add some randomness to how this guy rolls, you know, by maybe having a 10% chance of a tiny force acting upon it on the side, almost indicating a pebble. So we'll see the guy kind of just hobble, you know, or we can put enough little roadblocks in there and just let the physics engine kind of plinko its way through there. Kind of choose your poison. You know, we tried to do it for a few minutes. I think if we spent 10 or 15 minutes, we could probably get the guy rocking a little bit. But we kind of see you're playing this little game about how, you know, how the physics engine's working relative to what your colliders look like. That kind of stuff. You know, we probably could have maybe had a bunch of pin colliders. So, you know, it would have been a box collider that was really, really thin, and then have the bumps be sphere colliders maybe, but have them be fairly thin. So it was, you know, almost, I guess, kind of a cylinder-y type thing. And then maybe start the, when we first drop a pumpkin into the scene, start it with like a random rotation of, you know, either a little couple degrees to the left or a couple degrees to the right. So when he goes over that, it'll be exaggerated how it hits it. That kind of, you know, so you got to play with the numbers to fake the user out into thinking that, oh, something real's happening. All right. Okay, so this looks a little bit better. So we'll let this guy do the rest of his little thing here.
Click on it, and I don't think if you can see it, here it is. This is our sphere collider, this right here. Now, one funny thing that you're going to notice,
I'm going to pop ahead a little bit.
we'll explain in a second what both of these are. And but what we just do, this rigid body will apply gravity to this game object. If we don't have this rigid body, the pumpkin will not move as.
Yeah, so let me show that real quick, just so we're clear on those two things. If I click on the pumpkin, initially he did not add the rigid body. He just added the sphere collider. Okay, so I'll just right click and I'll remove that rigid body. So now I have a pumpkin that has a collider, but it doesn't have a rigid body attached to it. So when we run this, we see that this guy does not act like a solid object. Okay, he definitely has a collider, but he's not moving or anything for him to collide with anything. Now, if I drug him down and I forced the collision, or I wrote a script that made this guy move through space, not through animation, but because I told him to set a velocity on the Y to 10 or something, and he just darted towards the Earth, he would be able to collide because he has a collider. But we don't have natural or unnatural fake gravity acting on this guy, so those are things that aren't working with him right now. So if I go back in here and I add then the rigid body, now I can have gravity associated with this guy. And I'm going to talk about this kinematic thing. I think I mentioned last time. I'd mentioned more about it today. I'll talk about it here in a second. I don't think he talks about it, but I'll mention something about it here in a second. So now just adding the rigid body, by default, the gravity is on. The mass is 1. We can make the mass harder, higher if we want. But now he's a solid object that will fall out of the sky because gravity impacts it, and now he'll roll. Go ahead.
How is the floor not falling?
When you click the floor does not have a rigid body.
Oh.
So since the floor does not have a rigid body, it's not a, quote, solid object, but it has a collider.
Okay.
So he can react to other colliders, as we're seeing, right? We have 2 colliders that are hitting each other, all right? But he himself is not a rigid body. If we put a rigid body on there so let's just play this out a little bit. I'll go click add component. We'll add a rigid body to this guy, and I'll turn gravity off. All right. So now he'll act the same way he acted before from a not falling out of the sky perspective. Well, he's falling now. Okay. But now he's a physical object that can be impacted by other physical objects. Okay, we looked at this a little bit last time where I can go down to constraints and lock everything in and stuff like that. But in this case, we don't want this guy to do anything. He's visual only, right? Now, I'm going to go ahead and click kinematic on this guy. It's probably not the best example of it, so I might not be able to show you a great thing, but I think those look okay. Yeah. So when I added kinematic to this dude, this indicates that when I say he's kinematic, I'm saying that I don't want the physics engine to be the dude that says what this guy does when things hit it. I want to handle that through scripting. That makes sense? So I can have something be a solid object that may or may not have gravity, but I can choose to have external forces from other rigid bodies not have an automatic impact on him. Instead, I can choose to do that impact on myself. All right. Now, when might we want to have that? Let's say, if we have rigid bodies, we want to think about that in real life as being a solid object, right? If you were to throw something into the wall and it hits the wall or damages the wall or something like that, that's something that's a rigid body. Okay. So there are situations where we might want something to be, especially since we can write scripts associated with these things, we might want something to be a rigid body, but maybe not act like a rigid body all the time. Maybe not have other elements impact him all the time. And we maybe have seen this in games before. Let's say I'm just going to kind of make up a fake scene in a game. Let's say you're in a game and maybe VR is a good way of explaining this particular one. Let's say there's a table and there's an apple on the table, and you have I don't know, you have a spoon in your hand. That's your weapon, is a spoon. Okay, you might walk up to the table and you might start taking swipes, at the table. Well, maybe in that particular part of the scene, they shouldn't be able to knock the apple off the table, something like that. Okay, now, but let's say in a couple of minutes, once they get past 2 other little puzzle steps or something like that, maybe they're making a soup, right? And they're taking ingredients from the table with the spoon and putting it in there, and the 3rd ingredient is the apple. So we want that apple to be a rigid body, because he's gonna have physics and all this stuff acting upon him in a moment. But right now, we don't want things to be able to impact him. So we can't. Well, that's a lie. We shouldn't add components to a game object during runtime unless you have a really, really, really good reason to do so. So what we would do is we would add the rigid body to him prior to runtime, but we would turn off aspects of that component until we're ready to use those aspects. All right, so that apple would, it might act like a rigid body at that point, where if I roll something else would bump against it, but it wouldn't have an impact on those things. It would just prevent it from rolling through it. But then I can disable the kinematic when I'm ready to actually manipulate the apple, and then I would be able to pick it up and drop it, and it would act like a rigid body that has physics and stuff like that. All right, so in terms of practical uses of his kinematic, we might say that it's a good way of disabling physics temporarily. Something like that. All right.
As we just saw it while move. So the rigid body applies gravity to the pumpkin or any game object that is applied to. A sphere or a collider, any collider. This is a sphere collider. We have box colliders, we have mesh colliders, so on and so forth. Any collider will give like a solid body to the game object, because if we don't have a collider and we only have a rigid body, well, the game object is simply going to fall down. As you just saw, the pumpkin went down. It's not standing on another collider. And if you're wondering, when we created this cube, it has this box collider by default. So you see the box collider is attached by default on the cube when we created it. So if
there's a rule of thumb there, we might say that colliders impact other colliders. Okay, in fact, let's get that on a slide. That's a pretty important component here. Part of this is going to happen through practice anyways, but the more kind of rules of thumb we can get for how different game objects or components interact with each other, maybe the better off we'll be. Let's see if we actually have am I not on the network? Oh, we should be on the network. I'm streaming a video. Oh, snap. Probably a weird cookie thing or something. All right, so colliders interact with other colliders, and we'll actually see this programmatically when we're going to mess with something with colliders eventually. That's called a trigger, and we've already seen this. Well, you maybe didn't notice it, but if you go to a collider, you see this thing called is trigger that's here, and by default it's turned off. Well, the is trigger property says don't let these colliders do the normal physics thing. Instead, I'm going to programmatically handle what collision means between two things. For example, when Mario jumps onto one of the mushrooms, does the mushroom, does he bounce off of it or something like that? Does physics take place, or what happens? Mushroom kind of squishes down and then disappears, and Mario gets some points, right? So in that particular case, we wanted to handle that collision ourselves. We want to know about the collision, so in that case, the colliders needed to be involved. All right, but I want to programmatically handle that and say, okay, well, I'm going to play the animation for the mushroom guy to squish him down. Maybe it's not even an animation. Maybe I just, set his, since it happens so quickly, maybe I just set his Y scale to 0.1 or something so he looks flat. And then pop him so he's gone. So I delete that game object and then I give Mario some points. So we'll see that in a script, we can add a function for responding to a collision. And the parameter that comes into that is the collider a collider collided with. Yeah, the collider that a collider collided with. So if we have two colliders and this guy's a trigger, when he collides with another collider, this guy's function gets called and lets him know what collider he collided with. And it's important that happens because, for instance, we think about those little mushroom dudes. As they're moving along the ground, they're colliding with the ground, right? And we don't want to just randomly have the mushroom guy get flattened and Mario gets points just because the dude's walking along the ground. That collider is a collider we don't care about. So we only care about the collider that is Mario's collider. Make sense? All right, so we're going to be able to kind of granularly deal with things like that. But sometimes we don't want to rely on normal physics. Sometimes we want to do something gamey related to collisions. So that's what that is trigger is for. It allows us to programmatically handle it rather than having the physics engine handle it. All right, but colliders, from our perspective right now, these guys interact with other colliders. That's our magic. Two colliders can do things relative to each other. Okay. Now, do we already have a thing for rigid body? We do. So rigid body, we've said this is how gravity works. They do support collisions because if we don't have gravity on something, for instance, we removed the rigid body from our pumpkin before, that dude wouldn't fall out of the sky. So he's not moving, therefore a collision isn't going to occur unless something else hits him, something like that. So it's fair to say that it supports collisions. Okay, so let me go back to this.
The floor did not have that box collider. The sphere could not stand on it. We will see all of that through the course, but this is just a short explanation. So we want to change this sphere collider a little bit because it's right here. You see it? You see this little green circle right here? This is that sphere collider. I want to make it bigger. So we are going to change the properties right here.
Okay, I'm going to fast forward this. We did that already.
1. This is the set. 4. So 2.4 for the radius, and voila, we're good to go. And also for the mass of our rigid body, we're going to set it.
Yeah. So if you really want to use his numbers, click on the pumpkin, go to your sphere collider, and then you can set the center to 0, 1.91, and 0, and then the radius at 2.4. Let's see what ours ended up being on mine at least. Pumpkin. Sphere collider, mine is almost 0, 2.17 instead of 1.9, almost 0. In fact, we probably would just make these two things 0. And then maybe even make this guy a 2, whatever. And then he had his radius at 2.4. I had mine at 2.85, whatever. It's a ball that is roughly centered on the visual aspect of the pumpkin. Okay, so you can make yours whatever you want, but if you want to follow his exact numbers, feel free to put those things in there. I'm going to leave mine alone. But one thing I will point out is going ahead and making these guys 0 and 0 actually does benefit performance. So having this being 0 instead of negative 0.06, which is effectively 0, takes a lot of the math out of the equation. So one thing you will see is you'll see game designers, you'll see him do it several times, but you'll see him normalize those values so that they're roughly whole numbers, or if it's 1.24887, he'll make it 1.25, that kind of stuff, so that it's the numbers have less decimal points, therefore the math becomes a quicker math. Makes some sense? But whole numbers are always going to be the fastest. And we're targeting, oh, one other thing I wanted to point out while I'm thinking about it. I did look into because you brought up last time, the frame rate for what the eye can see. I would say, based on what I looked into, I'm probably wrong. I think you can probably construe some of the data as saying that the human eye is limited to 35, 40 frames per second under certain circumstances. But I found plenty of papers that kind of discussed, they were using a lot of times pilots who, let's say these guys have extra good eyesight, but doesn't matter, they're still a human, right? And they could actually detect artifact changes between frames, and I think they were operating at like 300 or 400 frames a second or something like that. And it wasn't just the smoothness thing. They could tell that this frame had a thing and this one didn't. So, yeah, I mean, take it for what it is. It seems like maybe more of the limiting factor then becomes like the number of frames on your monitor or something like that. But it looks like I think my knowledge was dated. I think that probably is the most accurate way of putting it. I think it was strongly believed that that was the case for a long time, but I think more recent research indicates that the human eye is a little bit better than we gave it credit for. Something like that. There's going to be some diminishing returns, though, so I'll still stick by that, the human eye is only going to, we're really trying to target smoothness with the human eye, but it seems like it can see more than 40 some frames per second and still detect data. So I'll make that correction. So thanks for bringing that up and made me look into it. So that's, updating my knowledge. So I appreciate that. So you get a star for the day. For last time, not for today. You were late today.
Want to make the pumpkin lighter, and we're going to set the angular drag at 0 because we don't want it to be dragged at all. And going back into...
We talked a little bit about this angular drag. At some point, we will have an opportunity to really see it in motion, but this has to do with so we have gravity. This guy's a solid object. When we think about solid objects, there's a texture to it, right? Some things are more gritty than others. So when we drag them across a surface, there may be a little bit of slowdown. If an apple was rolling down this table, both of these surfaces are pretty smooth, but you would expect there to be some tiny percentage of drag between the apple and the table just because of the two surfaces, rubbing against each other at some tiny level. This just takes that completely out. In many cases, it's less we probably wouldn't see the difference, and then it just becomes an easier math problem. So it's a performance thing if we take the angular drag out, unless we really want there to be a kind of a stickiness to something, which I think in the second game, we see an example of that. But generally speaking, we might make the angular drag 0, or we just leave it alone and just pretend like it doesn't exist because we don't care. One of those two. One of those two things.
The assets, right-clicking here, creating a new folder, which I'm going to call prefabs. We're simply going to drag and drop the pumpkin.
All right, so this is kind of his what we've been angling towards here. Where did he put that? He put it in his models folder. Let me just peek real quick and see where he put his prefabs thing. He put it just in assets, okay? So I'm going to go back to assets. I'm going to go and I'm just going to create a folder here called prefabs. All right, and I'll double click on that. And now what I'm going to do is we're going to say, okay, our I misspelled pumpkin. Isn't is that how isn't there another P in there? Is there 1 P or 5 P's? 3 P's. Okay, so we have pumpkin. So we got this guy working the way we want him to work, right? So now we can just drag him into this prefab folder. And now we have that pumpkin that we can create multiple instances of. So now whenever we want to generate one of those pumpkins, and we'll do this through some scripts next time, we'll get a copy of what we just created with all the extra work done to it. Does that make sense? All right, so that's what a prefab is. It's a kind of a completed object. Now, at some later point in time, let's say I go to this pumpkin, and I change his scale to 0.86 or something like that. Notice up here, it says prefab. I can apply that change to all the prefabs if I want. Let's just decide, I say, oh, well, this guy just isn't quite big enough. And I already placed this prefab in 50 different locations throughout my game. I can make a change to one of them and apply it to all the prefabs if I want to. So you're not completely screwed, but you do want to kind of remember what was a prefab and what wasn't a prefab. That kind of stuff. But they give you this little line here that helps you. All right, that makes some sense. Okay, do I have this week's Bible homework up yet? I don't think so. So I'll get the Bible homework up today. We'll hopefully get close to finishing this on Thursday. You'll have an assignment over the weekend to add some functionality to this that isn't covered in the video. We'll get into some scripting stuff next class. Sound good? Hey, once again, you are invited to join me in the front row of chapel. Plenty of room up there. I'll save you a seat. And otherwise, I will see you on Thursday.